in the array. Okay, so the time to reference any one element will be the same. Okay. But one limitation of array is that, okay, once an array is created, the size is fixed. If you want to put more elements into your array and you run out of capacity, then you need to create another array, an array of larger size, and copy all the data, okay, from the old array to the new array, and it takes time. Now, in some applications where the programmer may not know exactly, okay, what will be the size of the data set, and the data set, the size may grow and shrink, okay, in a very large range. Okay, so it is not convenient to use an array. Okay, and also for the insert operation, if you want to add something to an array at the middle, then you need to move, okay, all the existing elements. Okay. So another way to organize the data, to store the data in the memory, is to use a linked list. Okay. Now, a linked list is a collection of nodes. Okay. And every node contains two parts, the data and a pointer. Okay, the pointer points to, okay, the next node in the list. Okay. So graphically, we draw a node of the linked list in this form. So we have the data, and then we have a pointer. Okay, so the pointer will point to the location of the next node. Okay. Now, when we use a pointer, okay, there is a special value now defined in the language that is used to represent the case that we don't have a valid address, and we use it to terminate a linked list, or to represent the end of the linked list. Now, in the old days, okay, the constant, okay, now the constant, now capital, okay, is used to represent the null pointer. The physical value, okay, actually, okay, defined in the language is simply 0. Okay. So what happened is that you can have statement like this. You define an integer variable I, and then you say that I is null. Okay. But the meaning of this statement is simply you assign the value 0 to the variable I. However, okay, the text, okay, the word that you use may mislead that, okay, you want to say that now I don't have a value, I is null. But in fact, the actual meaning is not like this. The actual meaning is simply you initialize I with 0. And 0, in general, is a weighted value in most of the computation. Okay, so it doesn't mean that I is invalid. Okay, so because too many people make such mistakes, and the language designer later on, I think in a few years ago, they introduced another keyword in the language, null pointer. Okay, so if you define a pointer variable, and you initialize it with the null pointer, then it means that you tell the system, at that moment, I don't have a valid address. Okay, so this will be the same as writing P is assigned, okay, the keyword capital null, okay, the same effect. Okay, but the usage of, okay, the lowercase keyword null pointer can avoid, okay, the confusion. You cannot say that I, okay, an integer variable I is assigned the null pointer. Okay, then if you are writing this, the compiler will say that you have a syntax error because your statement is not correct. The semantics, the meaning of your statement is not correct. Okay, so that's why I modified the notes. Okay, in the past I used this keyword capital now, and okay, in this semester I revised the note such that we will use the now pointer. Okay, to denote that a pointer value is not valid, rather than this capital now. And I think the okay practice this day is okay not to use this capital now further. Okay, to avoid okay the confusion in the semantics of the statement. Now, if you in the following examples, okay, in general we will assume that the data value in the linked list are integer because it is easier to okay write down examples with numbers. But in general, it can be any data type. Okay, the data portion of a note can be any data type. Okay, and graphically, okay, when we draw the structure of a linked list, okay, we will draw the list from left to right. In general, okay. In the program, we will keep another pointer variable. Okay, that we use that variable to point to the first node in the linked list, and the name of this variable, okay, is usually called either say the head of the list, the first node of the list, or just okay call it the list. Okay, so those are commonly used variable name. Okay, that we use to refer to the first node in the linked list. And when we draw the linked list, okay, the length, that is the pointer of the last node, okay, should be equals to null. Okay, such that the program that process a linked list will know, okay, when it gets to the end of the list. Okay. Now, when we write the C++ program, okay, in different applications, we may need to deal with handle information of different types. So, in general, we will define the programs, okay, the function as well as the node structure. Define it using a template, such that we don't need to rewrite the code every time. Okay. So the general practice is to define a template for the node. Then the info field of the node is of the given type. Okay, and then the length is a pointer pointing to a node storing data of the given type. Okay, so this will be the syntax, okay, that in general we may use. Now the pointer variable, okay, in this case we use the name length, but in general we may also use the okay variable name next, okay, to represent okay the next node in the linked list. Now to find out, okay, next we will take a look at some example okay, program statements to manipulate a linked list. Now if you want to find out the length of a linked list, now when you have a linked list, okay, to find out the length of a linked list means that we want to count the number of nodes, okay, in the list. Now to do the counting, in general we will use a pointer variable. Okay, one commonly used variable name is p. like the index for referencing an array, we like to use the index variable is ijk, but for pointers variable, we may use a pqr. Okay, so this is one general convention. Okay. Now to find out the number of nodes in the linked list. Okay, so we will define a pointer variable p. Okay, we use that variable to traverse the linked list. Okay, so initially we assign the value of head to p, meaning that now the pointer p is pointing to the same node. Okay, as head. Okay, now to do the counting. Okay, first we initialize length to 0. Then we enter into a while loop. As long as p is not a node pointer, so we have not reached the end of the linked list. Okay? Yeah.
Why do we say node type P, not just type P? Like the previous line. No,
Because we are dealing with linked list of nodes.
So we make
Now, in the data type declaration, we define a node as a template with a type parameter. Okay? Now, the type parameters tell us that the info, that is the data portion that we store in a node, is of type T. Within the node, we have a pointer. This is the pointer. That points to the next node. Now, what is this next node? The next node is a node storing the data type type. Okay? So this is the syntax. Now, graphically, this part is storing an object of the given type, and this is a pointer that points to a node storing an object of the given type with together with a length also. Okay. Now all together, this is a node for a given type. Only this part is type. You still have the pointer. Okay. Now coming back to this simple traversal. Okay. Now as long as P is not the null pointer, okay, so it means that P is now pointing to a valent node in our data structures. We increment length, and then we move the pointer P, follow the length of the node currently pointed to by P, follow this pointer, and now P is update to points to the next node. Okay. Now when you are using a pointer to reference a structure, okay, you reference a data field within that structure or object. You use the arrow operator. When you type your statement, you won't put a space before and after the arrow operators. The reason is this together represent one operand. So it is one entity. So we won't put a space before and after the arrow operator. Okay. However, if you are doing other operations like addition, subtraction, divisions, multiplications, comparisons, okay, then you need to put a space before and after, okay, those operators. Now, why we want to put those space in between and after? If you want to compare the data of two nodes, okay, okay. Now, if you are doing the comparison, compare the data of two nodes. If you put the space before and after, okay, the greater than operators, you will see your statement easily. If you don't give a space before and after, okay, the operators, what you will get something like this on the screen, then it will be very difficult to read. Okay. And you may further have other operations. Okay. If you put everything in a line without space, okay, you just make your own life difficult. Okay? Now, I think let's take a break for a few minutes. Then after the break, we continue.
有嘅咩？